This is the first video that you are watching as a geometry student in my class, and the reason I put this video together is to give you a really clear idea of the skills that you need in order to succeed this year. So as you go through this video, I'm going to show you problems that fall into each of these categories. These are not the only skills you need, but these are pretty much the biggest ones that I feel if you can go into this year knowing how to do these algebraic skills, I think you'll be okay. So as we go through this is like your first big homework assignment of the year. It's going to be kind of a long video. Alright, what I want you to do along the way as you watch videos in my class is really utilize the strategy of pausing, copying the notes down, attempting the problems, and then pressing play to see if you got it right. That's the beauty of watching videos. They are interactive. You can go at your own pace. You can rewind and watch stuff over if you need to see it again. So right now what I want you to do is pause this and write down all of these skills as sort of a checklist of stuff that I'm going to go through right now. Here we go. Solving equations with rational coefficients. You see that the first 1, 2, 3, 4, 5 skills are solving equations. So you can probably assume that that's a big part of this course. So let's start with solving equations with rational coefficients. Rational, of course, means a fraction. Coefficient, of course, is the number in front of a variable. It's the number that's multiplied by the variable, essentially. Alright, so when we look at equations with rational coefficients, right, your job is to, of course, in any equation, find the value of x that makes this left side equal to the right side. So we have to figure out what that value is. So go ahead and pause this, give it a shot, and see if you can get the right answer. I'll work through it in a second here. You can press play and see if you got it right. Alright, so here we go. 3/4 times some number is equal to 7. When I see a fraction out in front of a variable like that, the first thing that I always do is I think about how they're connected. A coefficient and a variable are connected by multiplication. The inverse operation, I'll use that phrase a lot, the inverse operation of multiplication is division. Alright, so if you wanted to get rid of this coefficient and just get x by itself, you might want to divide by 3/4. Divide by 3/4. That's kind of a confusing endeavor though, because now you have, you know, fraction divided by a fraction and then a whole number divided by a fraction. So instead of doing that, that'll certainly work, but instead of doing that, here's a little shortcut for you. Let's multiply by its reciprocal. Multiply both sides by the reciprocal of this fraction. Reciprocal, of course, is the flipped over version. Those will cancel out, leaving us with x is equal to 7. I'll rewrite that as 7/1 times 4/3. So x is equal to across the top and across the bottom. 28/3. And I'm going to leave that as an improper fraction. I don't want to necessarily convert it to a mixed number or a decimal. If I did do that, of course, it's just division. 28/3, that goes in I think 9 times, so that would be like 9 1/3, which is 9.3 repeating. These are equivalent, but in most of our equations, if you get a mixed number, just leave it, or excuse me, if you get an improper number, just leave it like that. Number 2. So here we have -4/5 times some number is equal to 72/65. Again, you can divide by -4/5 on both sides, or we can just use our little trick. So let's divide by the reciprocal, or excuse me, let's multiply by the reciprocal. The reciprocal of -4/5 is -5/4. And what that's going to do over here is cancel those out, leaving us with just x is equal to, over here on the right we have 72 times negative 5 over 65 times 4. So we just multiply across the top and across the bottom. 72 times negative 5, let's see, that's 72 times 5, that's going to be 350 plus another 10, so 360 negative over, let's see, that's 240 plus 20, 260. I think I got that right. I'm just going to simplify this fraction. The zeros cancel, leaving us with negative 36 over 26. And they're both even, so let's cut them both in half. Negative 18 over 13. And again, that is a final answer. We're going to leave it as an improper fraction. So there was your first skill. Next up, solving equations involving the distributive property. Pause this, give it a shot, and then press play when you're done. So when I say distributive property, we're looking at basically a number that is outside of a binomial. In this case, the number is just a negative 1. So what we're going to do is take that negative 1 and we're going to distribute it by multiplication into both terms of the binomial. 34 is equal to negative 6 minus 8x. And now this is just a simple two-step equation. I'm assuming that you have this ability to solve. So we're going to add 6 to both sides, leaving us with 40 equals negative 8x. And then we're going to, of course, get rid of that negative 8 by dividing out by it. So we have x is equal to negative 5. Moving on. More distributive property stuff. I'm looking at a 4 outside of a set of parentheses, so I'm going to use my little arrows that'll help me multiply. So negative 3v plus 4 times 2v is 8v minus 32. Here we are combining like terms. Notice that this, I didn't even put combining like terms on the list of skills necessary to succeed in geometry because I expect you to already know how to do that. 5v, we're going to combine those, negative 3 plus 8 minus 32 is equal to negative 17. Add 32 to both sides, leaving us with 5v is equal to, what is that, 15 I believe, and then we'll divide by 5, we get v is 3. And there you go. Moving on, solving equations with variables on both sides. This one is definitely a big one. You're going to see this type of equation, these types of equations a lot in geometry. So here we go. We've got ourselves, our equal sign right here. So if you kind of want to think about that as the left-hand side and the right-hand side of that sort of that brick wall, if you will. When we move stuff over, we got to change the sign of it. Right? We have to use the inverses of it. So the first thing I'm going to do, actually, before I even do that, is I'm going to look at my right-hand side and I'm going to see that I can combine like terms. 7r minus 4r is 3r. And then I see that I can't really do any more simplification on any given side, so now I have to start sort of moving stuff across. And when I move stuff across, take a look at your coefficients of your variable, 4 and 3. Whatever one is bigger, keep that one where it is. 4 is bigger than 3, so I'm going to keep this one right here, and I'm going to take the 3r and move him over. It's not magic though, it's actually by using inverses. So what we're going to do, instead of just move it over, we're going to use the inverse of a positive 3r, which is a negative 3r. So I'm going to subtract 3r from both sides. What that gives me is 4 minus 3 is 1r, plus 2 is equal to 1. And of course, these cancel. Subtract 2, 1 minus 2 is negative 1. and you're finished. And as always, it might be a good time for me to say this. If you want to check your work, just take that R value and put it back into your original equation and see if it works. We're trying to find out if this works. -4 plus 2, does that equal 1 minus 7 plus 4? So that's -2. Does that equal 1 minus 7 is -6 plus 4? Turns out that -2 does equal -2. So that works. Alright, pause it, try this one. Variables on both sides and distributive property. We're going to take that -6 and distribute it, so it gives us -6 minus 12x equals 34 minus 7x. Again, the trick I use is I look at my coefficients of my variables. I look at which one's bigger. -7 is bigger than -12. I'm going to keep that one where it is, and I'm going to move the -12x over by adding 12x to both sides. That leaves me with -6 equals 34 plus 5x. The reason I keep the bigger one where it is so it kind of leaves me with, if possible, it kind of leaves me with a positive coefficient at the end. You don't have to necessarily think about which one's bigger, but I like to do that. Now I'm going to subtract 34 from both sides, leaving me with -40 equals positive 5x. Divide by 5, I get -8 is equal to x. Solving simple rational equations. Simple rational equations. Alright, so we have a binomial, which means we have two terms, divided by a constant is equal to a constant. When we have such a situation, what I want you to do is simply just multiply both sides by 5. Clear that denominator, leaving us with these canceling out, leaving us with just the top. Notice it doesn't change, it doesn't become 5x plus 15 is equal to 10 times 5. Subtract 3 and you're done. Something like this, we've got ourselves a binomial divided by a constant is equal to a distributive property. Same deal, we're going to multiply both sides by 6. On the left hand side these cancel, leaving us with just the numerator. And watch this, we got -2 times 6. Let's do that first. -2 times 6 is -12. In parentheses, -n plus 1. So we're going to distribute that. So we go here and here. N minus 4 equals positive 12n minus 12. Now we have variables on both sides again. I'm going to keep the bigger coefficient where it is, and I'm going to move that positive n over, leaving me with -4 is equal to 11n minus 12. Notice we can't forget about that -4 right there. It's a common mistake I see a lot. We're going to add 12 to both sides, leaving us with 8. I'll bring it up here. 8 is equal to 11n. And divide. Answer is 8 over 11. Nothing really fancy about that answer, but fractions are totally fine. Moving on. Solving proportions with algebraic expressions. Pause this, give it a shot, see if you can get it. Alright, so we're going to take our, I guess we'll just probably cross multiply this. Take this bottom number, multiply it up here. Take this bottom number, multiply it up here. When we do that on the left hand side, we have to remember to put that binomial in parentheses is equal to 9 times 4. 9 times 4 is 36. So now we're going to distribute 3x minus 3 is equal to 36. Add 3, divide by 3, which is 13. X is 13. And as always, you can feel free to check that back in. When you check it, 13 minus 1 over 9, does that equal 4/3? Well, 12 over 9 definitely equals 4/3. Cool. Pause it, try this one. Again, it's a proportion. Proportion is when two fractions are equal to each other. So you're going to take this 10, multiply it up here. You're going to take this 6, multiply it up here. Remembering to put your parentheses there, we've got ourselves some distributive property. 10k minus 10 is equal to 6k plus 48. I'm going to move my 6k over because it's smaller than 10k, leaving me with 4k minus 10 is equal to 48. Add 10, 4k is equal to 58, and we're going to divide by 4. So k is equal to 58 over 4. Let's simplify that. They're both even, so let's cut them both in half. 29 over 2. That can't simplify anymore. So I'm okay with that answer. I'm definitely okay with that answer. If you wanted to change it into a fraction, you certainly, or excuse me, a mixed number or a decimal, you certainly can. But for most of our problems, we're going to leave it like that. If you're curious, of course, that's going to be 14 and a half or 14.5. Now you might be surprised to know that in geometry we still use our linear equation formula. Our y equals mx plus b is what we call our slope. That's our slope. And b is our intercept. So this is called our slope-intercept form. That's our y-intercept to be specific. So if I'm asking you for the slope in this case, it's going to be the coefficient of x. Notice that there's no x on that slope. It's just a number. And that means that we're going to go down 5 on a graph and right 2. The y-intercept, which we give the variable, we assign the variable b to, is -5. It's the number at the end. And that would be where the graph crosses the y-axis. So if we had 1, 2, 3, 4, 5, this would be our first point. We would graph that first. Then we would go down 5 and right 2 and put another dot, down 5, right 2, and then we would simply just connect them, arrows in the ends. Simple as that. Something like this, if I ever ask you to tell me the slope and y-intercept of this, you would first have to get it into the right format. Y equals mx plus b. You can also get it into mx plus b equals y. They're the same thing. Doesn't really matter where the y is. So the y is on the right. I'm going to keep it like that. I'm going to add 20 to both sides. -8x plus 20, you can't combine those. They're not alike. Is equal to 5y. Divide everything by 5. So we get -8/5 x plus 4 equals y. And if you want to put it into more of the standard form where the y is on the left and everything else is on the right, you can do that. So you can see hopefully pretty easily now that your slope is -8/5, and your y-intercept is 4. How about these three? Give these three a shot. Pause it and see if you can, for each one, tell me the slope and the y-intercept of each one. Alright, this first one is y equals x. When y equals x, your slope is 1. And your y-intercept is 0. Alright, so if we were to graph this thing, it would simply graph, you would cross the axis, the y-axis at 0, and you'd go up 1, right 1. So it would look like this. Up 1, right 1. That's a slope of +1, really simple. Next up, the slope of something that is y equals just a number, well, that slope is 0. Alright, this is a horizontal line. And the y-intercept, this is where the graph crosses the y-axis, of course, is 4. So if we were to graph something like this, it would graph up 4 and it would be horizontal. And lastly, the slope of an equation that's x equals a constant, well, that slope does not exist. In other words, it doesn't have a slope or it's undefined. They kind of all mean the same thing. And this thing graphs vertically. This is a vertical line. The Y-intercept, of course, does not exist. And you might be thinking, all right, how does that one graph? Well, it graphs vertically at +7. So we're here. No slope and doesn't ever cross the y-axis. Alright, let's get into some fractions. This is not even algebra, this is like pre-algebra stuff, 7th, 8th grade stuff, maybe even younger. Let's start with some arithmetic. Add, subtract, multiply, divide. We're going to, when we add fractions, we want to find, of course, common denominators. In this case, our common denominator is probably going to be 8. So I need to change this one to something over 8, which is -4/8. So -4/8 plus 13/8. Well, that one is common denominators. You just add the numerators together, you get 9, and keep your denominator. 9/8 is an improper fraction. I'm totally okay with that as long as it's simplified, and it is. If you for some reason want to put it into a mixed number, it'd be 1 1/8 or decimal 1.125. Alright, here we go. Let's move on to subtraction. Again, we're looking for common denominators. We want a common denominator. So pause this, see if you can do this without a calculator, of course. We don't have common denominators, so I'm going to probably... The easiest way to find common denominators is just to multiply the bottom two together. It might not always be the least common denominator, but it'll always be common. So 8 times 7 is 56. So I'm going to change both of these fractions to something over 56. In order to change 8 to 56, I multiplied it by 7, so do that to the top as well. 3 times 7 is 21. In order to get 7 to look like 56, I multiplied it by 8, so multiply the top by 8 as well. That's 32. Now we have common denominators, so let's keep them that way. -21 minus 32 is -53. And we're done. If you can simplify that, go ahead and simplify that. Don't know if you can off the top of my head, but you know, if you can, just find some common factors in each and go from there. Moving on to multiplication, we've got ourselves a mixed number times an improper fraction. First, let's change this mixed number to improper. Remember to do that, we go this times 1, and then, so we're going to multiply that, and then we're going to add it to this. So this one's -6 plus 1, which is actually, we're going to just call that 7, so -7/6 times -3/2. Multiply across the top and across the bottom. At this point you can simplify if you want to. You can see that -3 and 6 will simplify, but I'll do that last because it doesn't always work. 21/12. 3 of course goes into both. 7/4. Positive 7/4. Division. Let's divide. Let me move this on up here. So again, you're pausing. As soon as you see the problem come up, pause it, give it a shot. When I divide fractions, I'm going to keep it the same. I'm going to switch this to multiplication, and I'm going to flip this over. I call that the old keep it, switch it, flip it method. Keep the fraction, switch to multiplication, flip it over. And now if you can, maybe I'll show you how to simplify first. You can simplify this, cut that in half, and cut this in half. Numerator is 5 times 5 is 25. Denominator is 2 times 17, which is 34. And you're done. Alright, let's get into our radicals, or our square roots. In this class we're going to be working with radicals when we get to some polygon stuff and when we get to some special right triangles and stuff like that. So it's important to know how to do this stuff. We'll start with simplifying. So write this down, the square root of 147. Without a calculator, simplify this into its most simplest form. And to do that, what you want to do is basically break that number up into factors. So we want to think about, all right, what numbers multiply together to get 147? Well, it's 1 times 147, of course. It's not even, so 2 doesn't work. Let's see if 3 works. Does 3 go into 147? Let's see. We've got 3 times 4 is 12 and 27. Yeah, 3 times 49. And that is kind of like a really, really good thing, because I noticed that, I'm going to write it like this, 49 times 3. I noticed that 49 is what we call a perfect square. A perfect square, of course, is a number that is the result of 2 numbers multiplied together to get it. 49, of course, is the product of 7 and 7. And when we work with radicals, we always want to be thinking about perfect squares. So here we go. I wrote 147 as 49 times 3. One of our radical rules is that we can break that up into 2 separate radicals. The square root of 49 is just 7. Get rid of the radical. Radical 3 we don't know. And that's our answer. So this guy is equal to this guy. But the one at the bottom in yellow is what we call the simplest form. So if you were to put those both into your calculator, this guy and this guy, you get the same decimal. But in mathematics, you always want to have the ability to write radicals in their simplest form without using decimals. That's, of course, an exact value. What happens when we try to add radicals together? We have this number in here is called the radicand. When they are when they are the same, you can just simply add them together. But you don't want to add, it's not, you don't do this. It's not 3 plus 3 is 6. That's not true. All you do is you think about this as like one thing plus another thing that's the same thing. So when you add 1 plus 1, you get 2 of those things. That's all. And that's your answer. So 1 radical 3 plus 1 radical 3 is 2 radical 3. It's pretty easy. What happens if you have something like this? Bring this right here. We got ourselves 2 radical 20 plus 3 radical 2 plus 3 radical 8. Alright, so we don't have, if you look at our radicands, we don't have like radicands. So right now we can't just add these together. So our first task is to get all of these radicands to be the same. And this is kind of our clue. 2 is of course, it's a prime number. You can't simplify that anymore. So that might help you to figure out what you need to simplify these 2 radicands to be. Can we change radical 20 into something with a base of 2? And I think we probably can. Let's see. We got, all right, 20, the factors of 20. Here's what we want to do. We want to say, all right, 1 times 20, 2 times 10, and 4 times 5. So 4 times 5, that's a pretty good deal, because that is what we call, of course, a perfect square. So I'm going to break this down. I'm going to break radical 20 down into 4 times 5. The 2 just gets put out in front, sort of like a coefficient. Plus 3 radical 2, that can't change. Plus 3, and then I want to break radical 8 down into something. Well, the factors of 8 are 1 times 8, 2 times 4. Again, we've got ourselves a perfect square right there, so that's a pretty good indicator that that's what you want to use. So break 8 down into 4 times 2. So here we go, 2 times 4 times 5. Break those up. Plus 3 radical 2, plus 3 radical 4 radical 2. 2. The square root of 4 is 2. So we're actually performing that operation of square root. Get rid of the radical sign once you do that. Radical 5, can't do that. Plus 3 radical 2. plus 3 times the square root of 4 is just 2 times 2. Simplify. 2 times 2 is 4. Radical 5 plus 3 radical 2 plus 6 radical 2. And here we go. We have radical 2 terms that can be added together. Remember one of our previous examples there, right above, we said 3 plus 6 is 9 radical 2. 4 radical 5 doesn't have the same radicand, it doesn't have the kind of the same base thing, so you can't add them together. So this would be a final answer right there. No calculators needed, pretty simple stuff. And by the way, you know you're finished when both of your radicands are simplified and there are no longer any perfect square factors inside of it. What happens when you multiply? When you multiply radicals. So when you multiply radicals, the rule is pretty simple. You want to multiply the things on the outside, so 5 times, there's a 1 here, so 5 times 1. And then multiply the things that are on the inside. So I'm going to change it to look like this. I'm going to move them both inside. 2 times 2 is 4. The square root of 4 is 2. So my answer is 10. And that little trick kind of works for everything. If you have like radical 7 times radical 7, that's just equal to 7. Radical 10 times radical 10, that's just equal to 10. Alright, the square root of something times the square root of that same thing is just equal to the thing. It's kind of like a basic rule. How about something like this, some division? Well, for this particular problem, I'm looking at the denominator and I'm saying, oh, I know the square root of 16. The square root of 16 is a nice, easy number. The square root of 16 is 4. Let me rewrite that. 4 radical 15 divided by 5 times 4. All I did there was I said, all right, what number multiplies together to get 16? And it's 4 and 4. So I write that down there and notice the radical disappears. 4 is on the outside and it's in the top. It's down here, you can cancel them. So it's radical 15 over 5. And that's it. That's a finished answer. No calculators needed, no decimals, no craziness, pretty easy. What happens when you have this though? We've got ourselves a division problem. The square root of 4 I know is 2. Square root of 3 I don't know. This is one of those sort of tenets of mathematics. You cannot leave radicals in the denominator. Not allowed. So in order to sort of eradicate that and get rid of that radical, we're going to perform a little trick here called rationalization. We're going to rationalize the denominator. When you rationalize a denominator, you basically just multiply top and bottom by that denominator. And what that leaves you with, I'll write it down here, in the top is 2 radical 3, the bottom is just 3, and you're done. That is actually equivalent to this. If you were to put it into a calculator, you'd get the same decimal, but the one that's in yellow here is way more acceptable in mathematics. That's what I want you to write right there. Alright, I think we're up to our last one, if I'm not mistaken. Here we have another craziness. We can't have a radical in the denominator, so what I'm going to do is rationalize. But the bottom here is like a binomial, right? There are 2 terms right there. So in order to rationalize a binomial, we're going to use this trick called rationalization again, but it's multiplying top and bottom by sort of the conjugate, what they call the conjugate of the bottom. And what that means, the word conjugate, is basically the same number here and the same radical here. The only difference is you change the sign in the middle. If it's a plus down here, change it to a minus up here. So we're going to multiply top and bottom by 4 minus radical 5. And when you do that, you're left with a distributive property. So you're going to take this 2 and multiply it by both terms on the inside. You get 8 minus 2 radical 5 divided by, we have basically have a FOIL. Let me get rid of some of this stuff. We have a FOIL in the bottom. There's a distributive property in the bottom that is binomial times binomial. When you have that, you do your first, outer, inner, last method of distributive property. So the first times first is 16. The outside is negative 4 radical 5. The inside is 4 radical 5. And the last times the last, let me highlight these. This is the last, this is the last. When you multiply those together, you get negative radical 5 times radical 5. But I think we already just said a few minutes ago that radical 5 times radical 5 is just 5 without the radical. Alright, so that's kind of a crazy thing, but it's really easy to simplify. Watch this. The bottom, the whole point of this rationalization procedure is to get rid of the radicals in the denominator, and watch what happens. Negative 4 radical 5 and positive 4 radical 5, they're exact opposites, so they cancel. So your denominator now is just 16 minus 5. So it's 8 minus 2 radical 5 over 16 minus 5 is 11. And none of that stuff can be simplified anymore. So we are good to go. That is our final answer. Alright, so that was about 37 minutes right there. That's a lot. However, hopefully you got a lot out of this. Hopefully you are addressing some of your deficiencies. Hopefully you're seeing stuff that you're really good at. And you know, the bottom line for all this stuff is, if you want to be really good in mathematics, you have to be really, really solid in your algebra skills. In order to succeed in higher level math, such as, you know, geometry, trig, algebra 2, pre-calc, calc, and into college, you have to be really, really, really strong in algebra. If you're not, then you're really going to struggle. You're going to struggle this year, and that is going to lead into struggles next year, and it's just going to continue to compound and get worse and worse for you as you get older and older. So practice your algebra. This video showed you the basic skills that you're going to need in this class to be successful, so practice them. All right, reach out to me during class or during office hours and see if we can get some more help. So hope you enjoyed this, and I'll talk to you soon.